In this video walkthrough lesson, we're going to take another look at our fractions module, and this is lesson 5-1.2, understanding and creating fractions equivalent to 1/3. We'll be featuring a variety of fractions, and they're all equivalent to 1/3. We'll be using fraction strips, number line, the array method, the area model, and we'll be handling fractions equivalent to 1/3 mathematically as well. And these are the standards that are featured in this video walkthrough lesson. We'll be using this worksheet. You can go to worksheetsandwalkthroughs.com to print out a copy for yourself. You'll find it under our fractions video walkthroughs section, and it's entitled Fractions Module Lesson number 5-1.2, Understanding and Creating Fractions Equivalent to 1/3. You'll also notice that page 2 of your printout would be fractions or blank fraction strips, and page 3 will be divided fraction strips. We have some directions. Fold a blank fraction strip in thirds, unfold it and label each section. Then lay the fraction strip below the number line and mark off 0 and 1 above the line, and 0/3, 1/3, 2/3, and 3/3 below the line. Then make equivalent fractions, 1/3, 2/6, 3/9, 4/12 in the chart below. And again, we'll be looking at the array method, the area model, and we'll be handling equivalency mathematically as well. Once you've cut out your fraction strip and labeled it in thirds, go ahead and take it and drag it up. Well, I'll drag mine up. You can just place yours above your number line. You can use the number line at the top of the sheet or flip it over and make a number line by hand that is just a little bit longer than the fraction strip. So as the direction said, we're going to take a look, labeling it 0 on the left end, and then as we read this left to right, we'll have 1 at the other end. Again, number lines help us to understand linear distance. In a previous lesson, we used an example of running a race, and each step along the way here would be 1/3 of the distance between 0 and 1. You could be running a 1 kilometer sprint, was our example, and if you stopped here, you'd be 1/3 of the way, 2/3, and finally 3/3, or 1 kilometer, 1 whole. So we're going to label below the line as well, like the directions mentioned. We'll start off with 0/3, then travel a distance 1/3, 2/3, then finally 3/3. And again, you can see that 3/3 would equal 1 whole here. Anytime your numerator and your denominator are the same, you have a fraction that's equivalent to 1 whole. All right, let's check this out. We want to take this linear thinking of 1/3, 2/3, and 3/3, our fraction strip divided into thirds, equaling 1 whole altogether. So we're going to take this thinking and apply it to our area model. You want to divide your fraction strips into thirds. I'm going to go ahead and do that. If you want to pause the video, you may do so at any time and just resume whenever you're ready. So we have 4 different area models we're going to do, and when you're drawing fractions, technically each area should be exactly the same, but in mathematical drawing, sometimes they're there to represent your ideas, so they don't really have to be perfect thirds for that. So now, to start off, we had the fraction 1/3, and we want to make fractions equivalent to that. So first of all, let's take a look at shading in 1/3. We're going to go ahead and do that. So let's go ahead and shade in 1/3 of that top area model on your sheet. So you can clearly see that we've got one section out of the 3 that make up this whole shaded in. So we'll have the fraction 1/3. I'm going to move a little bit quicker in this lesson. If you really want to get a more in-depth explanation, you can go to our previous lesson in our fractions module to check out fractions equivalent to 1/2. Now our focus is on 1/3. So we're going to take this and we're going to try to make fractions equivalent to 1/3. I'm going to go ahead and divide this next one horizontally across, dividing it once again. So we're subdividing here. We divided initially into thirds, and now we're going to subdivide it. So now we have 1, 2, 3, 4, 5, 6 equal parts. So essentially, we want to have an equivalent fraction. It's equal to 1/3, but now we have a denominator of 6 because it takes 6 equal parts to make up our whole in this case. It's the same area, however we divide it into 6 equal parts instead of 3 equal parts. So how do we do this? Well, in a previous lesson we noticed that we could think to ourselves 3 times what would give us 6. Alright, so we're going to go ahead and say 3 times, well, you're probably thinking 2. And if you're thinking that, good for you. You're right. 3 times 2 does equal 6. And what we do to the numerator or the denominator, you must do to the numerator. So we'll treat them the same. And again, we noticed before that we're multiplying the initial fraction by 2 over 2. And in essence, that's equivalent to 1. So we're multiplying it by 1 and not changing how much the fraction represents at all. And we'll prove that in just a second. So we've got 1 times 2, and you're probably thinking, oh, I know that one as well. And I'm sure you do. So 1 times 2 indeed would be 2. So we'll go back to our area model, and we're going to look at 2 out of 6. We'll shade in 2, 6. There's 1, 2. And then we've got it, 2, 6. And you can see that in the first model we did, we had 1/3, and that was shaded in. And it's the same area as 2, 6. That's because 1/3 and 2, 6 are equivalent. So in this one, we've got 2 sixths as our fraction. You can see that. You can see that they are equal. 1/3 does, in fact, equal 2 sixths. So now we'll go ahead and divide this up again. We'll handle it mathematically first. Let's check it out, see what happens. So we'll start with 1/3. You can go ahead and write that down on your sheet. And we want it to equal something. However, let's multiply it by a fraction equal to 1. So again, this is really like essentially the identity property of fractions or multiplication. So now why don't we try 3? All right, so we'll multiply the numerator and the denominator by 3, see what happens. So if we did 3 times 3, that would give us 9. We'll do 1 times 3, and that will give us 3. So, like I said before, if we're multiplying by a fraction that has the same numerator and denominator, you're not changing how much the fraction represents out of the whole at all. So we'll prove this once again. So now we've got 1/3 equaling 3/9. So we're going to have to subdivide this one to make 9 equal parts, or as close as we can get to it. Remember, you're just doing a mathematical drawing, and it doesn't have to be perfect, although I do want that to be a straight line across there. There we go, and then there. So it's looking like kind of like a tic-tac-toe board. In actual fractions, yes, the parts should be exactly the same. So they are equivalent, or they're equal-sized pieces. Well, and you want to remember that, because if you're sharing something among 9 friends, you want to be fair, and you want to give each person the same size piece. But in a mathematical drawing, it's really there to represent your ideas. So now, we're going to go ahead and shade in 3 out of 9. So, okay, there's 1/9, 2/9, 3/9. Oh, and look, as you can see, sometimes it's easier to see visually that they really are equivalent. And they are. Look at that. They represent the same part of the whole. Look at that. So now we'll just label this fraction over here. We've got this one would be 3/9, 3 out of 9. And then go down here, and we'll start off mathematically as well. You can probably see the pattern. We start off with 1/3, 2 6, 3/9. So we'll start off with 1/3 again. So we're trying to make equivalent fractions. A fraction is equivalent to 1/3. Let's see what we can do here. All right, and this we've multiplied by 2, by 3. Let's, of course, try multiplying both the numerator and the denominator by 4. See what happens there. All right, so we've got 1 times 4. You're probably thinking, well, that's the identity property of multiplication. You're right. That's 1 times 4 is 4. And then we have 3 times 4, and 3 times 4. You're probably thinking, that's 12. Good for you. So now we've got to prove visually or pictorially that 1/3 is equal to 4/12. We can do this. So somehow we have to divide this. So we have 12 equal parts. We've got 3, and I know that 3 times 4 equals 12. So let's subdivide it so that we have 4 rows. We've got 3 columns. Let's try to make 4 rows. I'm going to divide this in half first. And then I'm going to divide this section up top here, up, and down here as well. So let's see. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, 12 equal parts. Pretty much equal, that is. And we're going to shade in 4 out of the 12. Let's go ahead and do that. All right, so we've got 1/12, 2/12, 3/12, and 4/12. Aha! As you can see what's going on here. We've got this section. That is equivalent to this, equivalent to this, and equivalent to this. So 1/3 is equivalent to 2 6, 3/9, and 4/12. So let's go ahead and write that over there again. Aha. 4/12. So 4/12 is equivalent to 1/3. So therefore, it must be equivalent to 2 6 and also 3/9. Look at that. We have 4 fractions, and we've shown that they are all equivalent. Now, how would we handle this with the array method? So first of all, you want to set up an array based on your denominator. Okay, and in this case, we have a denominator of 3. And we want to show 1 out of those 3 with an array. And it's as simple as that. We've got this equaling 1/3. See, 1 out of 3 are focused upon here, shaded in, if you will, in this area model. Okay, so these are equivalent. Now we want to go ahead and create an array for 2 6. So I'm thinking, okay, 2 6. My denominator is 6, so my array will have a total of 6. And really this shows part of a set as well, because fractions can be applied to sets or groups, collections, as well as wholes. I mean, in this lesson and the previous lesson, we've chosen squares, or you could use rectangles. You could use circles to show these pictorially. A lot of times people use pizzas and pies to divide up and show fractions. But let's continue with our array. So we've got 2 6. 2 6. So how are we going to show that? Well, there's 1, there's 2 out of a total of 6. So this array represents 2 6, the fraction 2 6, or 2 out of 6. And you might be thinking, well, yeah, that's great, but how do I know that they're equivalent? Well, a good check would be go back to your basic fraction. Your fraction in simplest form, in this case, would be 1/3. So we've got our 1/3. See that? 1 out of 3 are shaded, are circled, or whatever you decide to do. And check this out. 1 out of every 3 up to 6 is also shaded in. Look at that. We circled 1 out of 3 there. And this group of 3, yep, 1 out of 3. So this 2/6 fraction would definitely be equivalent to 1/3. So let's continue our work with this array method. So you've got 3/9. You're looking at that denominator, I hope. Look at that. We have a denominator of 9, so we're going to make 9 parts of our array. 7, 8, 9. And you're probably thinking ahead. I hope you are, because you can see a pattern forming here. So we've got 1 out of this group of 3, 1 out of this group of 3, 1 out of this group of 3, or 1, 2, 3 out of 9, 3/9. There we go. That's our fraction 3/9. And if you look at it separately, it is equivalent to 1/3, because you can look at 1 out of this group of 3, and so on. And now we're going to move on to this last fraction. We've got 4/12. And I bet you're thinking that, yeah, this array should have 12. 1, 2, 3. See that happening? It's almost like 2 dice side by side. There's a 6 on the dice, 6 on the dice. Kind of visual thinking like that. It's a little picture into what I was thinking. You may look at it a little differently. That's fine too. So now we want to look at 4 out of 12. There's 1, 2, 3, 4. Again, it is equivalent to 1/3, because if you take a look, like way up here, 1 out of 3. 1 out of 3, see that? And then you can zero in on this. We've got 1 out of that group of 3, 1 out of that group of 3, and so on. It all makes sense, doesn't it? Now, you could continue this, really infinitely. Oops. We can continue it infinitely. You just have to change the number you're multiplying by. You could do by 5/5 or by 6/6, and you could just like repeat this and keep producing these equivalent fractions. And they're all based on 1/3. They're all equivalent to 1/3. So, you could really pause the video now or stop the video, because that's really all the worksheet tells you to do. However, we can show another. You can do a comparison of fraction strips. If you cut these out and you wanted to drag them over and see how they match up, like if I was looking at this 2/6 fraction, I would pick out my 6, and it's easy to see. We've got 6 equal parts here. 1, 2, 3, 4, 5, 6. We'll go ahead and drag this over here, show you. So if you line these up, and we had the fraction, I'm off a little bit here. Let me just move it over slightly. So you've got this fraction 1/3 right here, and you can see what it lines up with. There's 1, 2, 6. Look at that. Equivalent. Okay. Now we had a denominator of 9 for 3/9. So I'm going to look over here for 9s. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. Aha. You could cut that out, drag it over, line it up. Or you can make blank fraction strips, divide it into 9s. That's fine too. And you can probably see this pattern. We got 1, 2, 3/9. It's equivalent to 2/6. It's equivalent to 1/3, and so on. And now we'll look at that last one, 4/12. I got to find 12ths here. Might not be so easy to see visually, but let's give it a shot. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Aha! So this must be it. And we'll drag that over. Place it on there the best I can. All right, trying to line it up. Ooh, and it jumped on me. That's all right. All right, so now we should see 4/12 equivalent to the previous fractions we mentioned. So 1, 2, 3, 4, and look at that. And you can see that right there, right through here. Boom, 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 boom. They are all equivalent. You can see them all right there. All right, so that was a quick look at lesson 5-1.2, or understanding and creating fractions equivalent to 1/3. Thanks for checking out worksheets and walkthroughs.com. We'll see you again next time.